What do one of the most high-tech companies producing things for the aerospace and medical industries and mountain biking have in common? Well, today I find myself here at Fifth Axis, parent company of 5dev, where we're going to find out. I find myself here at building 1 of 5 then, and before I'm allowed even any further, I've got to do something I've never had to do before. Sign an NDA. Okay, so the reason I'm having to sign an NDA, because as well as super cool mountain bike parts, there's a lot of other classified projects going on here, which I'm not going to see, and I'm certainly not allowed to talk about. Let's get that signed. Right, onwards. From building 1 to building 3, and I find myself here where all projects start at engineering. And I'm going to look at how, well, this chunk of titanium turns into this. This is their brand new tie crank. I'm literally just seeing this for the first time. Let's head on in. So how do we get to something like this? Well, it's not as simple as you think. Here at 5dev, you'll have R&D, engineers, sales, marketing, all of those kind of departments will get together, brainstorm all around a big round table. And then once they've got their finalized idea, it's over to engineering to start making the mock-ups. So I find myself here in engineering and, well, there's nobody here. And that's actually because they're in one of those very meetings as we speak behind this door. Have no fear, the mechanical engineer is here, brainstorming away as to, well, how they get to this. The engineers are back from their meetings, they've worked their wonders, so from here we head to prototyping. Safety first. So let's head over to one of the machines. Do I look like Tony Stark? I feel like Tony Stark. Now there's all manner of machinery going on in here, from cutting, shaping, machining, just like this one here, the Doosan DVF 5000, where at the moment, 5dev also actually sponsor the Frameworks racing team of Nico Mullally, and they're currently cutting this in there. Have a look at that. So not only is prototyping done in the warehouse here, metal is stored as well. So everything that comes in, titanium, aluminium, it's all racked and stacked here. And once it comes in, the job is then documented all the way from start to finish. So whatever might be a crank cut out of this length here, they can pull up exactly what piece of metal was used, how much was required, and just the full process of it from start to finish. From building number 3 then, where the raw material is measured and cut to shape, in this instance, a trolley full of titanium, we head back to building number 1, where the safety specs are on, and this will start looking more like a finished bicycle product. Hey, how you doing? Good. Have a good day. Now, to get from that lump of raw material, it goes through various stages of operation. I don't really know how many, hence the NDA, and they refuse to tell me. They're a secretive bunch here at 5dev. But Op 1 I know is this. It has this dovetail cut in. Op 2 is where we're at here. You can kind of see a crank start take shape a little bit there. Op 3 is where we're at now, and it's loaded into this machine here. Now that'll be put into there, and then we're going to watch the wonders of whatever this crazy ass looking machine does work its magic. So what's going to happen in here, this machine's going to then start cutting out all the holes, all this excess material you can see around the base of it there, and you're going to have something looking a lot more like a finished crank coming out of it before it goes to the other stages. The process is now complete. It takes about 20 to 25 minutes to do it. However, we have what is resembling a lot more of a titanium crank. Now from here, this is where it starts to get real fancy. We got lasers and we got robots coming up next in stage 3. Now we're on to lasers and robots. Now because of this, these aren't needed. However, these are. Yes. Now, that crank that we saw in the previous process, this has a hollow in it, this new crank. It'll have a plate welded across the top of here. Now, 5Dev have got this machine specifically for that process. They don't use it on any of their other parts yet. And it's because basically this can weld it quicker and more efficiently and more consistently, giving a better finish the same time every time. Now, this is obviously a very expensive, very specialist, very delicate piece of equipment, so my sort of heavy-handed stonemasonry handedness is not really allowed anywhere near it. But one of the specialists is getting it set up as we speak, and I'm intrigued to see the kind of results that it's going to show over a more conventional welding system. The process is finished then. And this, it's a bit warm, is our finished product. Now this will head back to machining, where it will have splines cut in it, threads cut in it, and much more of a finished product. Now from here, we then take it to testing. And that's the part I'm looking forward to most. What's that noise, I hear you wondering? No, it isn't an old locomotive. We are in the 5Dev test lab, where this, which is hot from the machinist, will come here. We're on to testing now. Now, pretty much every part that 5Dev make will come through this part here. It will come through some vigorous testing. There are currently other sets of these cranks in the jig at the moment, which have gone through over 200,000 cycles. That's double the amount that they actually need to go through to be far exceeding any safety limits. But for those of you who haven't heard of 5Dev, and it's not just all about fancy tie cranks. They make aluminium cranks. We've got their stems in here. We've got bars and pedals are tested as well. And it just so happens that we're going to put one of their aluminium cranks into the jig right now and see what it can take. I'm not going to need these. We're going to sacrifice engineer Adam here, who's kindly opted to stay in. We'll seal him in, and I should say this is a one-way door. He cannot get out. Adam, increase the pressure. We are at 0.1 pounds. Oh my days. That's 725 pounds. Oh, 725 that was. Can we go higher?
We can go higher.
Let's take it higher. Fire in the hole.
Yeah.
Oh,
dear.
wow. 948. More. Come on, we go higher. Higher, higher. Even boss man Chris is nervous in the background.
That upset my stomach.
Have we maxed out the compressor?
Yeah.
Adam, we thank you for your services in there. Your sacrifice.
Should we let him out?
Yeah, we better let him out now. So we're going to bypass the what are we doing?
The regulator.
Bypassing the regulator. So basically, we're just going to max it out. We thought we'd maxed out. We're going to set a new max. And then we're gonna need more maths, and
Something's gonna break.
something's gonna break. I'm really enjoying this part.
Either the crank or my heart.
Yeah, fire in the hole. Holy
Jeez. Oh my God.
oh my day. Oh, that one's bent it that time. Oh, that one bent it that time. That was 1,169 peak pounds. That's as much weight as the world record back squat.
Oh my God. Something broken.
Oh, the spindle bent before.
Yeah.
So obviously the crank bent.
We're never getting it out of the test rig.
Oh my God.
And max out the cylinder.
Some nervous faces around 5Dev all of a sudden. So then this poor old R-Spec 165mm crank actually just got put through the most tough test that 5Dev have ever done here. And we put it on the table, and from first glance, it seems to have passed with flying colours. I'd still even ride that. But once things have moved on from here, once all kind of tests and protocols have been exceeded and they're happy with the results, it's then on to final manufacturing. And that then brings us here. Now, it may not look like much from the outside, but much like the Death Star, it's fully operational, despite not quite being complete. Come have a look at this. In this fully automated facility here, well, it's where the magic happens. No human power is needed, essentially, and they're able to turn raw material into completely finished product without having to lift a finger. That means a chunk of metal can be turned into this overnight without anyone having to do anything. That then is in part to this monster of a machine, the Hermle C650. Now this thing is ginormous and is potentially smarter than I am. What it can do is, once loaded up at the back, all the different pallets, as they call them, have various cranks loaded up, could be whatever, could be pedals on there. It's then fed through here automatically, machined on this side, and once finished, cleaned up, is then brought back, loaded back up onto the shelving on this side, and the new pallet is brought through. Now, the really clever part that they were telling me about this is the tooling that this thing can keep. So, because this thing is so big, it's riddled with all kinds of crazy sensors, real clever sensors. So if a tool is getting a bit blunt and it senses that the cut isn't getting accurate or sharp enough, that tool is then put to the back, a new one brought out, and it carries on all by itself. And this will run through the night. So with that then, let's let the machines do the work and turn off the lights. And just like that then, amongst the robots here at night, we've taken an insightful look at how some of the most innovative parts are made in the bike industry. I'm going to leave these things whirring away because it's creepy down here. If you've enjoyed the video, let me know in the comments down below. Thank you very much for watching, everyone. From me at 5Dev, I'll catch you next time.